The trend line that gives the most accurate model of related data is the line of best fit. One method for finding a line of best fit is linear regression. You can use the Linreg function on your graphing calculator to find the line of best fit. The correlation coefficient, lowercase r, indicates the strength of the correlation. The closer r is to +1 or -1, the more closely the data resembles a line, and the more accurate your model is likely to be. Consider this first scatter plot. We have scattered points not fitting to any particular line, and that would be an r value close to 0, representing no correlation. On this scatter plot, the points seem to be clustered pretty tightly about a line we can imagine that would have negative slope. This leads to an r value close to -1 and indicates strong negative correlation. In this case, we have a strong positive correlation. The lines seem to cluster pretty tightly about some line we can imagine with a positive slope. This would mean an r value close to 1. Problem 3, finding the line of best fit. This one's about food. You research the average cost of whole milk for several recent years to look for trends. The table shows your data. We see the title, cost of whole milk. The first row, year, 1998, 2000, 2002. Looks as though we're skipping every odd year all the way through 2008. And then our second row, the average cost for 1 gallon in dollars, $2.65, $2.89, and so on, until in 2008, $3.77. Part A, what is the equation for the line of best fit? How accurate is your line of best fit? Step 1, if we're using a graphing calculator, and by the way, we'll complete the same problem using Desmos graphing calculator following these slides. But step 1, on your graphing calculator, you can use the stat feature, its own button on the graphing calculator, to enter the data in your graphing calculator. Enter the x values, remember those are the years, in L1 for list 1, and the y values, the price, in L2 for list 2. We can simplify things if we let 1997 equal the year 0. So an x value of 0 would correspond to the year 1997. We can see what the graphing calculator screen would look like with our L1 values down the left and our L2 values in the middle. Step 2, we'll use Linreg to find the linear regression line of best fit for the data. Y equals 0.09x plus 2.53. And that was derived from the screen below. If we focus, we can see that the Linreg function on the calculator provided for us a sample of the form of the equation, y equals ax plus b, so slope-intercept form, and then below that provided values of a and b to create the equation of the line of best fit. Note it also reveals to us an r value and an r squared value. The r value can be approximated as 0.92. And we can state the correlation coefficient r is approximately 0.92. Since r is close to 1, the line of best fit is quite accurate. Part B, based on your linear model, how much would you expect to pay for a gallon of whole milk in the year 2020? Well, our equation, recall, y equals 0.09x plus 2.53. That's our line of best fit. We'll substitute 23 for x. Remember, x represented years since 1997, so if we input 23, that will correspond to the year 2020. Y equals 0.09 times 23 plus 2.53. Simplifying, that's 4.6. So we can state, in 2020, you would expect to pay about $4.60 for a gallon of whole milk.
Welcome to a quick video tutorial on using regressions in Desmos. Before we start creating a regression, we'll need some data. You can copy-paste data from Excel or a Google spreadsheet like this. Desmos even automatically adjusts the window to fit your data. Let's see how well a linear regression will fit. Our columns are x1 and y1, so we'll try y1 regressed against mx1 plus b. The twiddle, or tilde, means regressed against. And to get the subscript, just type y and then 1. I think we can find a better model for this data. Let's try a parabola instead. A x1 squared plus bx1 plus c. Nice. Looks like we're closer. Let's wrap things up by adding the residuals to the table. To do that, click the plot button here. That looks like a pretty good model. You can find more how-to videos, as well as our collection of interactive tours at learn.desmos.com.
So now we'll try the same problem using Desmos. Again, part A asked, what is the equation for the line of best fit? How accurate is your line of best fit? In this case, step 1, we'll load the graphing calculator at desmos.com. Step 2, click the plus button at the top left to create a new table. We'll select Table. Step 3, enter the x values, year since 1997, in the x sub 1 column. Step 4, enter the y values, remember that's cost per gallon, in the y sub 1 column. We can see the table at the right. Note that Desmos creates a scatter plot as you work. So as you're creating this table, Desmos will automatically plot those points. Step 5, create a new equation row in Desmos and type y1 tilde ax1 plus b. As the video described, this prompts Desmos to calculate values for a and b to complete the regression equation. Note that Desmos automatically graphs the regression equation you requested. Step 6. To respond to the second question, consider the correlation coefficient R provided by Desmos. An R value of 0.92 represents a strong positive correlation and an accurate line of best fit. Since Desmos also generated a scatter plot and graphed the regression line for us on the same coordinate plane, we can also confirm the accuracy of our line visually. The line includes or comes close to each data point in the scatter plot. This also suggests a high level of accuracy. Your turn. The table lists the cost of 2% milk. Use a scatter plot to find the equation of the line of best fit. Based on your linear model, how much would you expect to pay for a gallon of 2% milk in the year 2025? Use 1997 for year 0 in the equation.